Good morning, guys. This is Mr. Roden. I'm actually doing this on today, the morning. I got up early and made this. Wanted to see you guys, make you guys a video. Hope this video turns out to be helpful for you guys. We have a test tomorrow, and you'll take that test in class tomorrow. So be sure that you're watching this video and studying it. I will be around for any questions. So if you email me today, if you don't understand any of this, please email me. And I will see we can get you on my WebEx or something. So just email me, and then you can hop on my WebEx, and we'll make a time that we can sit down today or just meet and make sure you feel good about this. Our learning target today is I can solve problems that involve intersecting lines, parallel lines, and transversals. Otherwise, I can study for the test that's going to be up tomorrow. Okay, so this is going to be the last test of your second quarter grade. We will have some other grades, some homework grades, but this I think will probably be our last test. Okay, so you want to do really well on it because I'm going to weight this test very heavily. All right, good things. My good thing is that it was just a beautiful weekend, and I had a good weekend. I did a lot of math tutoring this weekend. So it's my kind of my second job is math tutoring. I do a lot of math, every day, whether it's with you guys or with high school students. So, but it was really good. I feel like the high school students were doing really well with it and felt like they were learning. So that helps. That makes me feel good when I can teach some math to some kids. All right, so we're going to do our study guide for the chapter test, and remember the test is tomorrow. So let's get right to it. All right, let's do it. Now, one thing I will say before I said let's get right to it, then I said it. One thing I will say is I'm going to try to make the test very, very similar to these problems, okay? I am going to add one essay question that's going to make you think a little bit, and I'm not going to tell you what that is. So besides the one essay question, most of the questions are going to look like these, okay? So if you can do these, you should be fine. If you want to ace it and get like an A++, then you have to have a good essay question. But these, if you can do all these problems, you should be fine on the test, and you shouldn't have any worries about getting a good grade. Okay, so here we go. So the first one says, find x and y. Well, the first one I see is y. Y is equal to 60 degrees. And that's obvious because y is vertical to 60. Okay, and I think hopefully at this point you guys understand what vertical is. And then when I'm looking at x, well, if x, you could look at it two different ways, but I'm just looking at it without having to move stuff around. This is a straight line. This is a straight angle. Those two are a linear pair. X and 60 are a linear pair. So I could write the equation x plus 60 equals 180. Simply solve for x. And we get x equals, 120. So piece of cake. I don't think you guys are going to need, and there'll be easy ones like that on the test. So those are easy points right there, right, guys? Awesome. All right, let's do the next one. Okay, in this figure, M and N are parallel. Name all pairs that have the same measure as angle 2. Okay, so the first thing I'm going to look at is, first of all, they're parallel, and that's important. So right off the bat, I know that angle 4 is congruent to angle 2 because it is vertical to angle 2. Okay, so I'll just do this, and then I can say angle 6 is congruent to angle because 6 is alternate interior to 4. Now there's a lot of different ways you could do this, right? 6 and 4 are alternate interiors, so we could say this. We could say that angle 8, because it's corresponding to 4. And I think that's it. I think it's just those 4 angles. Okay. And hold on. I got 4. I got 2, 4, 6, 8. Yep. So the even numbers are all, in this case, congruent to each other, right? And that'll happen. So basically, when you have two parallel lines and a transversal, you get it's all the obtuse angles are going to be congruent to each other, and then all the acute angles are going to be congruent to each other. And if it's a perpendicular, then everything's just right angles. So yeah, piece of cake, right? No worries there. All right, look below. What statement must be true in order to prove the lines are parallel? Okay, so M, let's just go through it. M congruent, 1 congruent to 3. So 1 and 3. Nope, that's vertical lines. So vertical angles. So vertical angles don't make lines parallel. They are congruent to each other. That's true, but it's not going to make the lines parallel. So this is no. Measure of angle 1 plus the measure of angle 2 equals 180. Again, that's a true statement. Okay, they do equal 180 because it's a straight line, but that's not going to make the lines equal parallel. Okay, that just means they're a linear pair and they add up to 180. That doesn't make lines parallel. So this is a no. The measure of angle 2 equals the measure of angle 8. The measure of angle 2 equals the measure of angle 8. Well, if they are, that would mean that alternate exterior angles are equal, right? So that would be or alternate exterior angles. So I think this one would be good. And let's see, measure of 2 plus 3 equals 180. 2 plus 3 equals 180. Now that doesn't do me any good either because that's just a linear pair. So I think the one that is good is 2 and 8 because there's a theorem out there that says if alternate exterior angles are congruent, then lines are parallel. Okay, so alternate exterior angles are congruent, then lines are parallel. So that's the key one you want. This is alternate exterior angles. Everything else I think is true statements, but it doesn't make the lines parallel. Okay, just because it's a true statement, like a linear pair or a vertical, doesn't make the lines parallel. Okay, remember what makes lines parallel. We could have same side interior. We could have corresponding. We could have alternate interior. And we could have alternate exterior. This is what make these 4 things make the lines parallel. Okay, if you have one of those, you're good to go. You can say the lines are parallel. Cool. All right, next one. In this diagram, angle 1 plus 2 plus angle 1 plus 3 equals 180. Okay. What do we know? So, well, we know that if 1 and 3 are equal to 180, so what's happening? We know that angle 1 is congruent to angle 3. Okay? And the reason we know that is they're vertical. The phone's beeping here. I got to take a look at that in a second. And then we also know that the measure of angle 1 plus the measure of angle 3 is equal to 180. So what's the only way that those could be equal and, in this case, supplementary? So they're equal measures, and they're also supplementary because that's the definition of supplementary when their measures out to 180. Well, yeah, they got to be perpendicular. The only way that can happen is these are perpendicular lines. Okay. So in this case, we can say the lines must be perpendicular. Okay, it's got to be a 90-degree angle. So that's the one we want there. Cool. All right, moving on. We're moving through this pretty fast. I think this is going to be a pretty. No, I don't know if it's going to be too easy, but there won't be. So far this has been pretty doable, right? Okay, use the answers in question 8 and 9 to the figure. Use the figure to answer questions 8 and 9. Line L is a perpendicular bisector. Okay, so remember what perpendicular bisectors were. That was the lesson from last Monday. So perpendicular bisectors, if a line is a perpendicular bisector, then the distance, these 2 sides right there are congruent. Okay? All right. So what is the length of AC? Well, AC is going to be 3 because it's got to be the same distance as CB. Which statement must be true? AD is equal to BC. So AD is equal to BC. No, that doesn't have to be true. Nothing says that this has to be congruent to that. So no. AD is congruent to BD. Well, that's true, right? So AD, if it's a perpendicular bisector, then this has to be congruent to this. AD has to be congruent to BD. I think that's true. BD is congruent to AD. So BD is congruent to AD. That's true. Again, that's just the same. I think AD, that's just that's the reflexive property, right? So if x equals y, then y equals x. CD, so let's see here. CD is congruent to AD. Nope. So it's going to be these two. These two. Let me just make sure. AD and BD and BD and AD. Yep, those two. Because why? Because it's a perpendicular bisector. Okay. All right. Use the figure below to answer the questions. Lines R and S are parallel. Which term best describes the relationship between 3 and 6? So where's angle 3 and 6? So this angle 3 and angle 6. Those are same side interior angles. Okay, they're on the same side of the transversal, and they're on the interior of the inside of the parallel lines. So same side interior angles would be the answer for that one. Same side interior angles. Cool. Which angle is supplementary to angle 4? Okay, so supplementary to angle 4. Now, there's multiple ones. If these lines, let's see, make sure. It says these lines are parallel. Okay, so R and S are parallel. So it's giving us that these lines are parallel. So in angle 4, what if truly they're parallel? Well, which lines are supplementary to angle 4? Which angle is supplementary to angle 4? Well, there's lots of them. 1 is supplementary to angle 4. 3 is supplementary to angle 4. And since the lines are parallel, its same side interior angle is supplementary to angle 4. So it's got to be one of those three. 1, 3, or 5. 1 or all of those three. So let's see here. 1, 2, it's got to be 1. The only one they give us a choice on is A. Okay, sounds good. Which explains why angle 7 is congruent to angle 3. So let's go back up and take a look at this. Why is angle 7, get rid of all this stuff, congruent to angle 3? So why is 7 congruent to angle 3? Think you know it? Well, yeah, those are corresponding angles. You can see right here in this purple set of angles right here, and then in this green set of angles right here, 3 and 7 are both on the bottom right. They're in the same position in their group of angles. So in the purple angles, 3 is the bottom right, and the green angles, 7 is the bottom right. So it's going to be corresponding angles on that one. Cool. All right, let's move on. All right, so now I'm getting into some delta math stuff. I know you guys have been working a lot on delta math, and I've given a lot of homework on it lately. And so I really want to test what you've been doing on delta math, okay? So the rest of the questions are just ones I've copied and pasted from delta math, and expect a lot of these type of problems on the test. So let's give this a try. So now these are dealing with perpendicular and parallel lines. So which equation represents a line that is parallel to x plus 3y minus negative equals negative 12. Okay, so I don't know. So let's solve for y. So if I have x plus 3y equals negative 12, and then I subtract x from both sides, so I get 3y equals negative x plus, or we could just say minus 12, and then I divide everything by 3, everything by 3, everything by 3. So what I get when I do that is I get, move this up just a tad, I get y equals negative 1/3 x minus, 12 divided by 3 is 4. Now, what's the key about parallel lines? Their slopes are equal, okay? So we want to find a line with a slope of negative 1/3. You don't care about anything else. All you want is a slope of negative 1/3. So which one? This one is no. This one is no. This one is no. So it's got to be that one right there because it has a slope of negative 1/3. And we're done. All right, let's take a look at this one. Which one is parallel to this one right here? Okay, so what I want you to do now is I want you to go ahead and pause the video and try the problem, and then I'll work it and see if you got it right. Pause. Okay, let's do it. So we have 5x minus y equals negative 1. And so I'll just simply subtract 5x from both sides. So now I have negative y equals negative 5x minus 1. And then this is really a negative 1. So I'll divide everything by a negative 1 to get rid of that negative next to that y. Switch all the signs on the other side. So I get, pop this up a little bit. So I get y equals a negative divided by a negative is a positive. 5x, a negative divided by a negative is a positive. So I get y equals 5x plus 1. Now remember, we only want parallel. So we only need this 5. So we want an equation with a slope of 5, positive 5. And it's this one right here. So is that the answer you got? If so, you're probably ready for this test. All right, let's keep moving on. Perpendicular. Okay, so what's the rule with perpendicular? So perpendicular, here's my upside down capital T. Perpendicular, M stands for slope. It's going to be an opposite sign. And then it's going to be an opposite inverse or an opposite flip. Okay, opposite flip. So which one? So if the equation is y equals 2x minus 8, so we just take that slope. That's really 2 over 1. So we take 2 over 1. We flip it, which is 1/2, and then we change its sign. Positive goes to negative. So now we have negative 1/2. So now what we have to do is go back to these, and we need to put them in slope-intercept form and figure out which one has a slope of negative 1/2. Okay? All right. So here, let's try number 1. So we have y minus 2x equals negative 4. This one right here. Adding 2x to both sides, I get y equals 2x minus 4. Nope, that's not true. Okay, the next one, all we do on this one is subtract 2x from both sides, and we get y equals negative 2x plus 1. Nope. Okay, on this one, let's solve this one right here. So we have negative x minus 2y equals negative 14. So first thing I want to do is I want to subtract x from both sides. So when I do that, I get negative 2y equals negative x minus 14. And then I divide everything by negative 2. I divide everything by negative 2. So I get y equals a negative divided by a negative is a positive. So positive 1/2 x minus plus 7. So nope, because it's not 1/2. Hopefully it's got to be this last one because I'm running out of options, people. So hopefully it's that last one. So let's solve that last one. So we have x plus 2y equals negative 12. We subtract x from both sides, so we get 2y equals negative x minus 12. Divide both sides by 2, everything by 2. And so I get y equals negative 1/2 x minus 6. And there we go. There's our negative 1/2 that we wanted. So it's got to be that one right there. And we're done. Hopefully, if I went too fast with that, let me know. Email me if this, because I will put some of these on there, okay? All right, which equation represents the line perpendicular to x equals 0? So if you look at x equals 0 on the coordinate plane, where is the line x equals 0? So if this is your x-axis and this is your y-axis, if you're looking at the coordinate plane, what is x equals 0? Well, that's just the y-axis. X equals 0 is the y-axis. So which line is parallel to the y-axis? Okay, so y equals 4, perpendicular. Y equals 4, well, that's probably pretty good. So, so that's going to be like that. right? At 4, that's y equals 4 right there. 1, 2, 3, 4. So this one looks good. Let's just check everything else. X equals negative 4. Nope, because x equals negative 4 is going to be something like this. We'll make it green line. X equals negative 4 is going to look something like this. That's not perpendicular to the y-axis. That's parallel to the y-axis. So nope. X equals negative 2y. Nope. And then x equals nope, because if you solve for y, you won't get that. So it's absolutely going to be this first one. And we're done. Because just to make sure that you see that red line is perpendicular to the y-axis. Okay, sound good? All right. Moving on, Mr. Roden, moving on. Okay, find the value of x and y. Well, the first thing I know is that 6x plus 15 equals 7x minus 6. And I know that because they're vertical angles. So we can just go ahead right now and solve for x. So I like to attack the weaker variable. So I'm going to subtract 6 x's from both sides. So I get 15 equals x minus 6, 1x minus 6, or x minus 6. And then I'll simply just add 6 to both sides. So I get x equals 21. Okay. So now if I know x equals 21, maybe I'll just put it in for this angle right here and figure out what that actual angle is. So 7 times 21 minus 6. Well, 21 times 7, 7 times 1 is 7, 7 times 2 is 14. That's 147 minus 6. Hopefully my math is correct. And then 147 minus 6 is 141. So this is a 141 degree angle, which would make sense because it's obtuse. So now we know these two are supplementary. They're a linear pair. So now I can say that y plus 141 equals 180. And then I can just subtract 141 from both sides. So I get 180 minus 141, 8, 10, 9. This is a 7 minus 4 is 3, so I get 39. So y equals 39. And if I did my math right, 39 plus 141 should equal 180 degrees. All right, how about this one? Well, these two angles are linear pairs of each other, right? So we can say that 7x plus 12 plus 9x plus 8 equals 180. All right, so 7x plus 9x is 16x. 12 plus 8 is, I believe, 20, equals 180. And then let's see here, we'll subtract 20 from both sides. And so I get 16x equals 160. And I believe I just divide both sides by 16. And if I do my math right, I believe that 16 goes into 160 10 times. Is that right? 16 times 10 is 160. So x equals 10. And I'm done. Moving on. Lots of problems here. Okay, your job is to figure this one out right now. You should have a reason why you set those equations or what you did with those equations, and then solve it for x. Go ahead and pause the video now and solve for x. Hey, I'm back. So what relationship do these two angles have? Well, we kind of talked about it earlier. These two angles are alternate exterior angles. They're not alternate interiors. They're on the exterior. They're on the outside of the parallel lines, but they're on the alternate sides of the transversal. What we know, if the lines are parallel, which it says they are, then the alternate exterior angles are equal or congruent. Their measures are equal. So we can say that 8x plus 19 equals 9x plus 9. All right, so hopefully you got that because they're alternate exterior angles. And then I'll simply attack the weaker variable. I'll subtract an 8x from both sides. And so I get 19 equals x plus 9. And then I'll subtract 9 from both sides, and I believe I get x equals 10. Is that what you got? Do you agree with me? Hopefully you do. Hopefully you do. Either you're wrong or I'm wrong or both right. So hopefully we're both right, and we'll be happy about that, right? Awesome. Okay, I want to pause the video on this one, and I want you to give this a try. You need to find x, and you need to find y. Hey, welcome back. So let's see here. What can we do here? Well, I can, right off the bat, I can say that 7x plus 13 is equal to 9x minus 19 because they are, again, alternate exterior angles. They're on the outside of the parallel lines, and they alternate on each side of the transversal. So the next thing I'm going to do is I'm going to subtract 7x's from both sides. And so I get 13 equals 9x minus 7x is 2x minus 19. And then I'm going to add 19 to both sides. And then so I get 2x equals 19. Let's see. So 9 plus 3 is 12. Carry the 1. So I get 32. So I get 32 equals 2x. And I believe that 32 divided by 2, if we divide both sides by 2, is x equals 16. Hopefully that's what you got. Hopefully my math is correct. I'm not going back and checking my math, so if I made a mistake, I'm sorry about it, but hopefully that is true. So now we know that x equals 16. So let's go ahead and put that into this equation right here, okay? All right. Well, you know what I'm going to do? Oh, no, let's put it in there. So I have 9 times 16 minus 19. And that is going to give me, let's see here, 16 times 9. 9 times 6 is 54. Carry the 5. 9 times 1 is 9. Add 5 more is 14. So we get 144 minus 19. So let's see here. That becomes a 3. 14 minus 9 is what? 5, right? 14 minus 9 is 5. And 3 minus 1 is 2. So we get 125. So this angle right here is 125. So we get 3y minus 17 plus 125 equals 180 because those are supplementary, right? All right, so let's go ahead and do the math here. So a lot of arithmetic here. We got to take negative 7 minus 17 and 125. Let's put those together. So let's subtract 17 here. 15, let's see here, 15 minus 7. Let's see here, is that, so that's 8, right? And then this is a 1, so this is 108. So 3y plus 108 equals 180. Subtract 108 from both sides. Really hoping my math is right here, guys. So now I get 3y equals, that's a 7. 10 minus 8 is 2. 7 minus 0 is 7. So I get 3y equals 72. Sorry, this is just a complete mess here. And then divide both sides by 3. And 72 divided by 3. 3 goes into 7 2 times. That's a 6. That's a 1. That's a 12. 3 goes into 12 6 times, right? 3 goes into 12, 4 times. 3 times 4 is 12. 0, so I'm getting 24. All right, so I get, here's my answers. X equals 16 and Y equals 24. Do you agree with my math here? No, there's a lot of things I could have done wrong there, but I don't want to make this video too long and go back and check it. I'm thinking I'm probably right, but all right, let me know. Email me and tell me, Mr. Roden, you made a mistake, and I'll check it out. All right, let's do one more and call it good. So let's see here. Let me just find one I want to do. I have 2 more. 3 more. I don't want to do all of them. Let's do this one. This one looks pretty good. Okay. So we want to find X and Y. All right. So what I would do right now is I would find, I'm going to just call it this angle Z. Because if I know angle Z, then I'll know angle X because they're what do you call it? They're vertical to each other, right? So the way to find that angle is I know I have, so from here to here. Oh, so angle Y is all the way from here. Okay, so that's fine. So to find angle X, all I need to do is just remember there's 180 degrees in a straight line. So if I take 26 degrees plus this 90-degree angle that they give me, plus angle Z, I know that has to be 180 degrees. Now, that's not supplementary because supplementary only involves 2 angles and we're involving 3, but they still equal, it's just angle addition postulate. There's 3 angles and they equal a straight line. So 26, so this is 116 plus Z equals 180. And then I'll simply just subtract 116 from both sides. So those cancel out. So now I get Z equals, all right, so let's do the math here. 8, that's a 7. 10 minus 6 is 4. 7 minus 1 is 6. And then so I'm getting Z equals 64 degrees, which looks pretty good. That looks like a reasonable answer. So that means X has to equal 64 degrees because they're vertical. Okay, so X equals 64 degrees. Now let's clean this up here. Let me get rid of all this stuff here. Okay, so now we want to find Y. Okay, so now I'm going to look at this straight line. I'm going to look at this from here to here. Okay, so I know that 64 plus 26 plus that given 90. No, sorry, I'm not going to do that. My bad. I'm going to do. So that's easy. So if we know this is 64, right? So Z is 64, duh, and Y is 64 plus 90. So all Y is equal to, Y is just equal to the 64 that we found for Z, and then we just add the 90 on, and that's going to give us our Y. So 64 plus 90 is 154. 154. And we're done. Okay, guys, so I'm going to try to make the test like this. A lot of these delta mathy type of problems, some of those earlier problems that we did, that kind of easier, which is identifying alternate interiors and stuff like that. Plus an essay that's going to make you think, maybe a word problem, something that you're going to have to think about. So if you want to get that A+, you gotta have that higher knowledge. But I'll put a lot of this stuff on there, so you should be prepared watching this video. I hope this was helpful, guys. I know some of you say you like the Monday lessons, some say you don't. But I always try to make it a real lesson, and that's why I put my face in here so you can see me, and it feels like I'm here teaching you today. Okay, guys, email me if you have any problems today. I'm going to post this right now. I'm going to upload it to YouTube, and I hope you guys have a wonderful day, and we'll see you tomorrow for the test. See you later. Bye.